So, thanks for joining me this afternoon. Thanks for coming to my session. Officially, hopefully, I am better at giving technical presentations than I am about writing titles, because this might be the worst title I've ever come up with. But this is building Azure Infrastructure with PowerShell Azure Functions inside Azure SQL Databases. So, if you like any of those things, hopefully this session will be fun. Before we get started, it's important to thank our sponsors. We can't do these events, and we wouldn't all be here without them. Stop by their booths, grab some swag, maybe some chocolate. I think Chocolatey should definitely bring chocolate to these events, right? But I did give that as feedback previously, and they're like, yeah, it's an idea. But I don't know. Anyway, make sure you stop by, thank the sponsors. We couldn't do this without them, and so it's really important. This presentation all came about because I saw a cool blog post, and I was like, you know what, that would make a cool session. And this blog post, also not a great title, was Azure SQL Database External REST Endpoints Integration Public Preview. And what this blog post talked about was the ability to call, to natively call REST endpoints from within your Azure SQL databases. And this is just an Azure thing. This is not in the on-prem box product. But from within our Azure SQL database, we get a stored procedure, SP Invoke External REST Endpoint. And it gives us the ability to call REST endpoints, which I thought was pretty neat. And you can see in this picture some of the things you can call, some of the things you can do, right? API management, Power BI, Azure Functions, which I already love, so that was super interesting to me. And then I started thinking, I'm a database administrator by day, and so I love inventory systems, and I love keeping track of my estate. So I started thinking about how traditional inventory systems work. Usually, we have an estate of servers out there, right? Maybe they're not all Windows, maybe there's some Linux ones out there too. They have SQL instances, one, many, who knows? And then there's a bunch of databases on them, right? And as a DBA, I like to know what databases we have in our estate. But for me to keep track of them, I need some kind of hero, right? Which is where DBA Tools comes in. With DBA Tools, I can go out and I can collect all that information, and then I can store it in my inventory database. But this is very much like reactive, right? I've got my estate out there, and I'm going to go see what it looks like and then record it in my database, maybe daily, maybe hourly even. I also like to think about infrastructure as code. And whenever I'm doing a bit of a research project, the first place we go is obviously Wikipedia, right? Infrastructure of code is this idea that we're going to manage and provision computers using machine-readable definition files, right? Basically source code to define our environment. So if we put these two things together, could we create an inventory system that's actually the single source of truth? The database, the table named SQL DBs is not just recording what databases we have in the wild, but maybe it's provisioning them, right? We add a row, we create a database. So with that endpoint call that we can make from Azure SQL Database, this kind of idea of having an inventory system that was actually the single source of truth came about. This is me. My name's Jess Pomfret. My pronouns are she and her. I'm a data platform engineer for Data Masterminds. I'm also an open source contributor and a LinkedIn learning instructor. If you are interested in learning more about T-SQL or DBA tools, I've got a couple of courses out there now. The most important stuff on this slide, though, is my contact details. If you want to chat about PowerShell, football of the proper kind, not the American kind, SQL Server, databases, whatever, find me on LinkedIn, my email address, or I have a blog on jesspomfret.com. So back to the presentation, back to this idea. We've got this SP Invoke External REST Endpoint stored procedure. It is a system stored procedure within Azure SQL Database, and it gives us the ability to call allowed endpoints. We'll talk about what an allowed endpoint is in a second. One thing to note, this is a public preview feature. There are no SLAs at the moment, and things probably will change. So these demos today will work today, but maybe tomorrow some things have changed and you'll need to adapt them. But I think it's pretty cool, so we're going to go ahead and take a look at this stuff today. Most endpoints that you have out there are not going to be open, right? We're going to need some kind of authentication to basically say, to basically authenticate, tell you who we are, and that we have access to that data. And we can handle that with database scoped credentials. There's two things that matter for these database scoped credentials. The first one being the name. The name of this has to be a valid URL. It has to be a domain in the allow list, and it needs to be more generic than the request URL. You can see my example here is calling an Azure function, and it's /API/new storage account. So I can call that endpoint or anything after that. I can't call /API/get storage account. If I had named it just /API, I could hit both those endpoints with this credential. So some planning is needed there. The second important part of this database scope credential is the identity piece. And there are three ways that you can use this to handle different kinds of identity. I think we'll look at 2 or 3 of those today at least. The final one is managed identity, and you can see I've got that in my example. Managed identity for Azure is super cool. If you haven't played with that already, definitely look that up. But it basically allows us to have this passwordless solution of allowing resources to talk to each other, right? We can basically tell our Azure SQL Server about our Azure function, and we can give each of them access to the other. So we don't need to create users. We don't need to create keys. We can just say this function has the ability to talk to that database. Pretty magic. Now, database folks, when they see this presentation, are going to be, whoa, what are you doing in my database? Like, what about my performance? And Claudio loves SQL Server performance, so this slide is for him. There is some throttling. We're not going to completely destroy the SQL Server by calling these APIs, right? We're going to cap the connections that you can have at 10% of worker threads to a maximum of 150. And depending on how your Azure database is provisioned, that'll be enforced at 2 potential levels. Either if you've just got a single database, it will be enforced at that single database level. If it's within an elastic pool, it can be enforced at both the database and the pool level. Okay. Final note on here, the wait type, right? When I call that API, it's going to have to wait for the response. And while that's happening on your SQL Server, you'll see this HTTP external connection wait type. So which APIs can we call? I mentioned earlier there's an allow list, right? An allowed endpoints that we can call. And these are some of the ones that I think are cool. So Azure Functions, I mentioned already, those are basically serverless bits of code that you can write, right? And now you can call them and execute them from within your database. That's going to be pretty much the basis of our final demo today. So we'll come back to that one. We've also got logic apps, event hubs, cognitive services, I think is pretty cool. Within Azure Cognitive Services, you can have anomaly detection. So if I have a table in my database, so I work at a consultancy company and we have clients with databases. That helps. And every day we'll go out and we'll collect information about those databases, right? Tables. How many rows is in each table? With anomaly detection, I can take that data and I can call out to Azure Cognitive Services and say, hey, this is my user table. This is how much it grows over time. Everything cool. And Azure Cognitive Services will say, well, this table usually grows by 1 row a day. And today it grew by 1,000. Like there's some anomaly, right? Something's weird. So I can kind of make my databases more intelligent with using some of these Azure services with these REST endpoints, which is pretty neat. Power BI. It tells me you can execute DAX queries against a published data set. Power BI is something I know very little about. Even looking at it is hard for me. But those are words, and you can do that with this endpoint. IoT Central, and finally, API management. API management is super cool because it allows you to publish APIs, and then you can call any of those APIs from your database. These are the 2 we're going to focus on today, Azure Functions and API management. One other thing about API management, the ability to reach out and get data, right? We could use that for many things. Maybe we need to supplement the data we have in our database with something else. We could collect weather data or some other kind of external data and bring that into our database to use, which is pretty neat. Okay, so let's talk about the first demo we're going to do, and we're going to use that API management tool. So I've got my Azure SQL database. and I've got the ability to call that endpoint, right, from SP internal. Why do I keep saying internal? SP invoke external REST endpoint. And I'll pass in some parameters, right? This is going to be the get method, a URL, and then I'm going to get a response. I'm going to hit API management, which is the tool in Azure that will provision. And that allows us to connect any APIs that meet the Open API specification, which is like this general specification for writing APIs that a lot of people are using now. API management basically creates a gateway out to that API, where I'll get some data, and then we'll put it back into the database. So we'll hop into Azure Notebooks here, Azure Data Studio, Azure Notebooks, and we'll set this up. So there's a few prereqs for this to work. The first being that we need to create am I bothering this? We need to create an API management instance, and that is, it takes a little while, so we'll provision that ahead of time. We'll then be able to add and publish an API through that API management instance, and those APIs can be open or secured. If they are secured, we'll need a subscription key, and that's where our database scoped credentials will come in. If we move over now to the Azure portal, you can see what we're looking at our API management service. There's some basic information on this screen, but let's take a look at the APIs down on the left here. Pass, Jess, come on. As I mentioned, this takes a little while to provision, but once you have it, you can go into here to APIs, and this is where you'll define your new API. I've got a couple already in there, demo conference API, and in the middle now you can see the endpoints that are available. If we take a look at get speakers, that's going to get speakers, and you can see the endpoint is just /speakers. There are a couple of parameters available, but I just want a full list of speakers, so I'll hit that endpoint as it is. This endpoint is secured, so we need to set up our database scope credential. For that, the first thing we need is a master key. Obviously, we will have a proper password, and it will be nice and strong, but we'll create the master key, and then we'll back it up and keep it safe. That allows us to use database scoped credentials within Azure SQL. Once that's created, we can then create our database scoped credential. You can see here, this one's got the name of /conferences/speakers, and I'm using the HTTP endpoint headers to pass in my function, to pass in that subscription key. Now these two things are in place, we can actually call that API and do something with the data, right? Now, there is a slight bug with Azure Data Studio and Notebooks in that when I get this JSON response back, I can't click on it. Real useful. I have opened an issue, and hopefully they'll fix it soon. But you can see we're going to call SP invoke external REST endpoint. I've got my credential ready to go so I can authenticate. And then I'm going to use JSON query just to pass that data, and you'll be able to see it returned as JSON. You can see I've got one row affected, status 200, meaning it was successful. Again, I can't click that, so let's just run it in an Azure SQL, just a regular query, so we can interrogate that JSON a little. So the result is collection, there's items within it, and then a whole list of speakers with their URL. That's great. It's still not relational, right? And I'm going to put it in my database. But now that we're able to get the data, we can store it in an attempt table, and then we can use some other JSON language keywords from T-SQL, such as JSON query, to pass that out and create relational data from our API. So this is pretty cool. Like, this is obviously a simple example of getting a list of speakers that maybe doesn't change very often. But if you wanted to pull in like today's weather and match it up with your sales data, you could easily reach out to an API, grab that, and store it in your database, which I think is pretty neat. To take this one step further, we can think about Azure Functions. Does everyone know what Azure Functions are? Using them, doing cool things with them? There's a bunch of other sessions at this conference. I would recommend checking them out. That basically gives you the ability to run bits of PowerShell in the cloud in a serverless fashion. I don't need to think about the infrastructure. I just run code in the internet. It's cool. To make up an Azure function, we basically have the function, which is the code. Obviously, it's going to be written in PowerShell because we're at the PowerShell Summit, PowerShell PSConf. There'll be some kind of trigger that kicks it off, and then there will be bindings. The bindings help you to connect to other Azure resources. Bringing it together, we get an Azure function. I wanted to do a quick segue here to talk about how we can develop Azure functions, because I think this is super neat. Obviously, I'm going to use VS Code. If you're not already using VS Code, highly recommend you check it out. There's a lot of powerful stuff in there. One of them being dev containers. Dev containers give us the ability to define our development environment in code so that when you download my repo and you open it, you get the exact experience that I get. The same extensions, the same plugins, the same profile, whatever. It's all can be customized. Once I develop my function in my dev container, I'll push that code to GitHub. Then some magic happens, right? GitHub Actions. You can have GitHub Actions run when you push code, when you have a pull request, all kinds of triggers for that. But what it'll do is it'll deploy my function code to an Azure Function app. Now, this sounds like, if this is the first time you're hearing about this, you're like, okay, that is a little step too far. But if you create your Azure Function app in the portal through the GUI, it'll actually say like, oh, where's the code? And you'll say, oh, it's in this GitHub repo. And the GUI will be like, oh, take this workflow file, I'll even put it in your repo for you. And it'll hook all this up for you. So any change you make to your function code, you push to GitHub, and then it magically updates your function app. Super cool stuff. If you haven't played with dev containers yet, April Edwards, the PowerShell hero from earlier, has a session on Wednesday called Every Repository Needs a Dev Container, and that is a true fact. One other thing, if you're in the keynote earlier and you heard about the PSConfEU PowerShell module, that's what I'm using here to display the schedule. Also neat. So let's pop into VS Code and talk about dev containers. So if you open my repo, and this is out on GitHub, if you download it and open it locally, what you'll get is a pop-up in the bottom right-hand corner that says, hey, you've got a dev container. Shall we open it? And when you click, yes, please, that's awesome, it'll reload your window and start to create those containers. You need Docker or Podman or something running in the background, but now we'll create we'll create a container that will basically develop inside. You can see in the bottom left, I'm in a dev container now, and the name of it. If you have a repository and you want to add a dev container, if you press F1 or however you get to your command palette, and you type in add a dev container, you can actually follow this wizard and use one of the templates that they already have to add all of the code you need to start customizing it. Once you add that, you'll get a folder in your repo called dev container. And you can see there are a couple of files under that, a JSON file, and in this case, a Docker file. If we take a look at the dev container.json, this is basically the description of my environment as code. There are some extensions. Oh, let's talk about the top first. So this one is built on the Azure Functions and PowerShell template, and it uses a Docker file to define the container. You can see that it is coming from the Azure Functions PowerShell Core Tools container. You're free to layer up things here. If you want to add things to your Docker file, you can do that. But this is just a basic example. Secondly, we've got a bunch of extensions. These are VS Code extensions that I think are useful, like my to-do tree, so I can keep track of what I'm supposed to be doing. I've got a code spell checker, because my spelling is terrible. And I've got some Azure Functions tools in there as well. And GitHub Copilot, because AI is everywhere, right? The last thing in this dev container is features. Now, these are kind of self-contained pieces of code that you can add in that are already developed. So if I want to add in the Azure CLI, I can just add that feature, and it will be within my container when I get there. You can see I've got the Azure Functions core tools installed, which means that I can develop and work on these functions locally. If we want to develop a function, we want to create a new function, we can again use the command palette and VS Code to walk through that. I'm going to do Azure Functions create function, and it'll ask me what kind of template I want to use. I'm going to use a HTTP trigger, which just means I'm going to call that endpoint, and that will trigger the function. We'll give it a name of PSConfEU test, and we'll use function authorization. You can see I've got a folder that's been created from that action, and it's got a couple of files in it. Run.ps1 is a PowerShell script. If you're already writing PowerShell, this is going to feel super familiar. At the top, I am getting some inputs. Those are coming from the request. When I hit this trigger, when I hit this endpoint, I'm going to get some data about it. I wrote a quick message, and then I passed out the name that came through the parameter. Finally, we're going to push to the output binding. In the other file, function.json, this is where we defined our bindings, which is how we're connecting it up. And you can see I've got an input binding, which is the trigger of a HTTP trigger. And the output binding, you'll notice, is also HTTP, but called response. And that's how we push back to that at the end. Since I've got those function tools installed and I'm within my dev container, I can run those locally. So I'll pop into my functions folder and run func start. And you can see in a second, I'll have 3 functions that are now running locally on my machine. No need to deploy to Azure. We can test this all locally. You can see that 2 of them are HTTP triggers. So I've actually got endpoint URLs that you can hit. And then I've got the SQL one, which we'll talk about later. If I hit that endpoint by clicking on it, we'll get a pop-up. And you can see that the HTTP trigger function executed successfully. There is an option to pass that parameter. So if I add the name of Jess, you can see that it'll handle that, right? And this is just logic within my PowerShell. Whatever parameters you're expecting, you can pass them through and then choose a path through your code based on those. This is not only a really simple example, but if you open VS Code and you say create a function, HTTP trigger, this is what you get. You can do this in like 30 seconds on your own laptops. And then you can just build onto it from there, get more parameters, do different code paths, whatever. It's pretty cool. So that's a really simple function. Just to show how we can develop Azure Functions, we can test them locally. For our next demo, we're going to actually want to create some Azure Infrastructure. This is going to be the basis of our storage account example. Again, we'll start with our Azure SQL Database with our SP Invoke external REST endpoint to be able to reach that endpoint. This time, the endpoint is going to be a function. I'm going to trigger an Azure function from my Azure SQL Database. That is going to create storage accounts in Azure. Databases was my original example, but it takes a little longer to provision. Storage accounts, you can just quickly create them and kill them off, right? So the idea here is that I will insert a row or I'll have a row of a storage account I want to create, and I can call a function that will do the work. So let's pop back into Azure Data Studio, and we've got a notebook to walk through. The requirements of this, and this is obviously just an example, but this Azure SQL Database table is going to become my single source of truth, right? Adding a row should create a storage account. Deleting a row should remove the storage account. Modifying rows, who knows? I haven't thought this through. There are some questions still existing here, right? How does the data even get here? Well, maybe another API. Maybe you've got a change management system and there's some kind of an approval process. And when you want a storage account, it gets approved and data gets put in my table and the storage account gets provisioned. There are some prereqs for this to work. One being the function to do the work, right? So let's pop back to VS Code and take a look at our function. Again, we've got that folder which encapsulates those 2 files. This one's called new storage account. And if I take a look at the function.json, we can see how these bindings and triggers work. Looks pretty similar, right? I've still got the HTTP trigger coming in, and then I've got the HTTP trigger going out, still named response. If I pop over to run.ps1, this PowerShell is it started as the exact same basis as the first function. Still got inputs coming in. I'm writing a message which also goes into log analytics, which is super cool when you're running this in Azure. And I'm getting the name of a storage account from the parameter passed in, and then calling new AZ storage account to create a storage account. Finally, I'm going to do some work to create this body object, which will basically be passed back as a HTTP response. Did I create the storage account successfully? What's the name of it? And a few other details. Obviously, this is going to be behind some kind of authentication, right? I don't want anyone to be able to create storage accounts for me in my Azure portal. So we're again going to need some authentication setup, which is where our database scoped credentials come in. Again, managed identity is the best option here. To mix things up for the demos, I'm going to use function authentication for this. So I can just use that function key that you get from Azure to authenticate. If we don't already have the master key, we again need to create the master key before we can create any database scoped credentials. And it should have a proper strong password. Then I'll create my database scoped credentials. This time you can see I've got my function name /API/new storage account, so I can create those storage accounts. And the identity is that HTTP endpoint headers, passing in that function authorization key. Once those two pieces are in play, we've got my name of my storage account, which I'll pass through the URL, making sure it's in lowercase. And then I'll call SP Invoke external REST endpoint with the credential to hopefully create a storage account. Again, I'm running this in the notebook because I love Azure Data Studio notebooks, but that means I cannot click on the response. But we should be able to see that the code is 200 and the description is successful or okay. So I created a storage account. Everyone believes me, right? That's fine. We'll move on. Okay, let's prove it. Let's prove it. If we pop into PowerShell on the Windows terminal, I can use get AZ storage account. I'm just passing the tags and saying that it was created by my function. And you can see that's the name we passed through. And that has been now created. Pretty cool. Neat. Cool. Well, then I saw another blog post and I was like, whoa, this is even cooler. And I just went, I have this thing with rabbit holes and squirrels, and this happened. So I saw this blog post by Drew where he was talking about developing with Azure SQL bindings and Azure SQL triggers. So I believe the bindings are generally available now. The trigger is still public preview at this point. Yeah, so again, be careful, things might change. But this gives us the ability to fire a trigger, to fire the Azure function based on SQL data changing, which then meant we could do something different, right? We can have our Azure SQL database, and the action of inserting data will cause the Azure function to fire. We now don't need a stored procedure. We don't need that really cool stored procedure that started this whole demo, this whole presentation. Sorry, Rob. Now we're going to use something even cooler. We're going to use the SQL binding to get that data changed to then create storage accounts based on data changing, which is even neater. So if we pop back into Azure Data Studio, I've again got a notebook. First thing we're going to need is some tables. Cool thing here is I put those comments in there, and then GitHub was like, GitHub Copilot was like, I'll create a table for you. So don't judge me on the data types because that was Copilot. But now we've got some tables. For these SQL bindings to work, they use change data capture. So we'll need to enable that at both the database level and the table level. And that basically creates this stream of data changes that our function will pick up. If we pop into VS Code and check out the function, the bindings this time, we're going to use a SQL trigger instead of the HTTP call. And I'm specifying the connection string, which Azure SQL Database, and the table, DBO storage account. That's what I'm going to keep track on and look for changes. And this time I've got 2 output bindings. You can have as many of those as you want. I'm just going to have a response, and then I'm going to log it to a SQL table. If I check out the PowerShell, which is what's going to run when my function is triggered. Oh, the connection string, sorry. It's in local settings here, and you can see I'm using managed identity. No passwords here. You can use this locally in VS Code, and then you can publish them to your function app. This time I'm getting an object of changes. So with that, I'm going to need to loop through it and handle those changes, because if in SQL Server you can have batches, right? So I can have multiple changes at once. For each change, I'm going to create a storage account. I'm splatting the parameters here. I'm only changing the name, but I could just as easily get the location and the SKU. Finally, we're going to push back to that log table. So we should see that happen. For this function, we're going to watch it in the portal. So this is my Azure Function app, which is basically the container for my functions. And if I check out the functions, you see I've got 3, 2 being HTTP triggers, 1 being a SQL trigger. And if we click into the CDC storage account one, and we head over to monitor, we can actually watch this as it fires. Changing over to the logs pane, and I'm going to change to watch the file system logs just because that seems to happen quicker. We can see it as once it's connected, we can see it actually receiving those requests. Okay, so now we're going to insert 2 values into my storage account table. You can see 2 rows affected. And if I review those tables, I've got 2 rows of storage accounts, but no rows of log data. By the time I get back to Azure Portal, it's already fired, right? The trigger's already been like, oh, we got changes. And you can see that it's creating the first storage account. There is a lovely warning here that the behavior for creating storage accounts is going to change, which is an interesting point. If this is running in a serverless fashion, I'm not going to see that, right? So I need to keep a kind of heads up on the release notes for these things. Now it's moved on to create the second storage account because it's looping through the changes that it received, and it had 2 new rows. And once that storage account is created, you should get like a final executed successful message from our function. In your own time. Come on, past Jess. Well, this is actually Azure, not even past Jess. All right, executed successfully. It took about 6 seconds, I think. 60 seconds? Yeah, total. Final proof, we've got our 2 new storage accounts that were created just by inserting rows into an Azure SQL Database table. To prove it, you can see I've also got my log message. I've just basically concatenated the results and put it into this log. But you could do something a little cleverer probably to make it easier to parse at the end. But that's pretty cool, right? This opens up a whole bunch of like ideas and other things we could use this for. Anything you can write in any of the Azure Function languages, you can now call from your Azure SQL Database. You could make application calls. You could process some data that you have in your database. You can create storage accounts or do Azure Infrastructure tasks. Are any of these things good ideas? I'm not sure, but these are possibilities, right, that we can play with. Another thing that's worth mentioning is this data API builder. And I've got a link in the slides, which are available on my GitHub, to a blog post that Joey D'Antonio wrote about this API builder. But it basically allows you to create an API on top of an Azure SQL database, which means that you can then get and set data from that database with API calls. So with these 2 things kind of tied together, we can do some other interesting things like move data from one database to another, basically kind of inserting data across a link server in Azure. Again, good ideas, only time will tell, but possibilities. So this session, I mentioned that the title was terrible, and then I had a second title, which this session kind of turned into a plethora of tech that Jess thinks is neat, because we've been through like 10 different cool things in 30 minutes, 33 minutes or so. But one of the things I do is I love to go to conferences, I love to talk at them, I also love to go to sessions and learn things, and then take them back to my team. So what I usually do is I write down the things that I want to look into more. It wasn't a deep dive, but these are some of the things that you could take back from this session and play with more. Dev containers. So cool. Definitely play with those. Me and Rob have a session on Wednesday about using dev containers for our DBHX module. They are a literal lifesaver. It makes it so easy to work together on things. Really cool. PowerShell Azure Functions. Just the ability to run PowerShell in a serverless fashion is, I think, super neat. Azure SQL Database. I'm a database administrator, so I got to give a shout out to my relational database friends. GitHub Actions for basically reacting to code changes, right? Running tests, deploying functions, APIs, and finally the PSConfEU PowerShell module that Rob wrote is a great way of staying within PowerShell and seeing what else this great conference has to offer. We've now made it to the question and answer slide. All of this whole repo, my slides are available on my GitHub. If you download it, it will be in a dev container and you can play with these functions immediately. And again, my contact details. We can chat here. I can answer questions. You can stop me, buy the snacks. But if you think of something in the middle of the night, probably my email is a better idea. Any questions? Rob. Rob's question is, what's for lunch? Because I asked him that in the keynote. It was a staged question. I wasn't just hungry. But yes, lunch was good. It was turkey rolled up. delicious. Yeah, it's good. Any questions about this? Yes. Great question. So the question was managed identities. You can have system assigned or you can have user assigned managed identities. Are both supported? Yes, both are supported. Yeah. You just need, I forget which piece you need, but the documentation for these functions will take you through how to create that, and you just need the app ID or whatever it is, whatever that GUID is. But yes, both are supported and both work. Great question. Other questions? Yes.
Can you mix C# and other Azure PowerShell functions in a single function?
Great question. The question was, can you have multiple languages within your one function app? And no, the function app container can only contain one language of functions, but you could have multiple function apps. So you could have a function app that has your C# code in and a function app that has your PowerShell code in, and then you can call those separate endpoints. That would be cool though. But I think when you create a function, the way that it kind of sets up is slightly different depending on your language. So I'm not sure whether that would even be a possibility in the future, but there's no real restriction on how many function apps you could create. Obviously, you're like, well, budget, but functions are pretty cheap compared to other Azure stuff, right? But like app settings and stuff would have to be duplicated, which would be a pain, but yes. Just do it in PowerShell, it's cooler anyway. Yes?
Are there currently any limitations from using private endpoints in combination with database and the function app? So has to be called with a really public endpoint, or can it go to your...
Ooh. Good question. So the question is whether you can call private endpoints on your functions, not just the public endpoint. I have no idea, but I imagine that you could call private endpoints. Yeah, check the documentation, and if you can't and you want to, fire an email to the Microsoft team, because this is still in preview and they're working on things. So if they know that those are requirements that will be needed, maybe it's something they can do. Not sure. Good question. Yeah, agreed. Final questions? Or front of the snack line if there are snacks. I don't know. There's no snacks. Front of the coffee line. Cool. Well, thank you so much for joining me for this 45 minutes. I hope you enjoyed all this random tech, because I think it's super cool. And hopefully this gave you some ideas of things that you can play with some of this stuff. If you do think of questions, I'll be around all week. And I like to talk about nerdy things, so stop me. Thank you.